Okay. Good morning, everyone. How is everyone doing? Oh, yeah. That sounds like it was a long party last night. All right, so next up we have Andrew and Erin. They're both working at Google. Andrew is part of the Angular team for a year now, right? Yeah, that's right. Congrats. Oh, no. So we should do a happy birthday to you. Like happy work anniversary kind of song. Yeah. Okay, we'll figure that out. And so you can see his work in the tabs and the tooltip and the table components. And before that, you worked on the analytics products, right? Yeah, cool. And Erin, you're on the Google Analytics team, and you've been contributing to Angular material as well. She's the author, or the main author of the MD panel component in Material 1. And she enjoys powerlifting and desserts, just like me. Desserts is a good thing, too. Yeah, so please welcome Andrew and Erin.
I'm going to get logged in here. All right. Hey, good morning, guys. Welcome to the Angular Material Data Table Talk. My name is Andrew Seguin. I work on the Angular Material team.
And I'm Erin Coughlin. I work on Google Analytics. Together, Andrew and I designed and built the Angular Material Data Table. So today we're going to start with a little bit about our design, and then we're going to go into more details about our templating and our data source, and then finally we're going to end with a demo. So I have a bakery.
All right.
So we're going to look at an app that we're building for our bakery. So first, the design.
Cool. All right. So like all good features that we have in Material, we start with an empty GitHub issue. No description, just a real short title. But we could tell by the reactions on the bottom that people were really excited about this one. We got hundreds of party emotions and smileys, and I think 6 people were sad that we were doing this.
I think they're sad that we didn't have it, that we don't have a data table.
So they're happy now.
Hopefully everyone's happy now.
Hopefully they're happy now.
Or now,
hey,
look, there's the Angular Material Data Table. So this exists.
It's
you guys can use it today.
Out of beta. If you guys didn't see the news, we're out of beta now.
And so what does this table support? So it supports sorting,
paging,
filtering,
inline editing,
selection,
virtual scrolling,
sticky columns and rows,
custom cell templates,
animations,
drag and drop support for column reordering,
and everything.
Everything. It supports everything.
This table supports everything.
Amazing. Thank you.
So how did we support everything?
How did we do that? Cool. OK. So when we first started this design, we talked to a lot of people internal to Google. We talked to a lot of customers. We figured out what are the list of features we want to put into this table. And it turned out everybody had their own way of what they wanted, right? So the material spec does define, like, this is what a table looks like. But some teams said, my paginator should do this, or my sorting should do this.
Some people wanted dense layouts, others wanted comfortable.
Yeah.
Custom
Everyone wanted
filtering.
a different kind of thing with this table. So there was a challenge here.
And so, like we said, some people want a very simple roller coaster. Just goes up and down, displays a couple rows.
Some people want a table that look like this, right? Does everything and twists and turns and...
It's crazy.
Yeah, it's crazy.
And so what we ended up coming up with is we didn't have to build the Angular Material Data Table. We can create a foundational data table that we then could build on top of. And in doing this, we could support everything and allow you to do the same with all of your features.
So what we did, we took a step back and we said, what is the table? What are its responsibilities? What can we really focus on that you could build on top of? And what we found is that there's 2 parts. So first part, you got your layout, right? You want to render rows of cells very efficiently, very performant, in an accessible way so anybody can see them. Second part, you got the data source. And that's kind of the brains of the operation, right? What rows do I want to show to the user? And we found that with these 2 guys, if we do them right in a flexible way, not over-engineer it, you could build anything on top of them. And we looked through our feature spreadsheet. Everything was good. This would fit that model.
And so we're going to go into both of these ideas, so the layout and then the data source. So first, the layout. We began by looking at all of the tables out there. And almost every single person designed what we call a row-based layout. So it looks something like this. You have a header row, you define a bunch of cells in a header, and then you define what a row looks like, and a bunch of cells in that row. And then the table goes through and it just repeats for row and row. So this looks like an HTML table.
Looks good, right? And this is what the code would look like. So you've got a container for a row, you put a bunch of cells in there, you say what it should be, and you imagine the table will render out all these rows. Pretty simple.
Yeah, and so if we put it together, we have the header row, the data row. Again, it looks like the HTML table here.
We liked it. This was good. We're off to a good start. It looked simple to use. It was intuitive. It made sense, right? You give it data, it shows the rows. We're good, right?
Yeah, until we went back and started looking at some of our features. So we had sticky columns as a feature that some teams wanted. People wanted to reorder columns or hide those columns for mobile devices. So your 10-column table, that's not going to work on a phone. And we noticed there's a lot of copy and paste. There was no reusing what a row is or anything like that. So we felt like we were at a dead end here.
So we took a step back, went back to the drawing board, and said, we need to redo this layout. We need to do a template that has a little bit more control. So we met with the core team. We met with a lot of customers. We met with as many people as we could, and it took a few months. But we ended up coming with a design we liked, right? We thought outside the box, and it kind of flipped itself on its head.
Yeah, so instead of thinking of a table as a bunch of rows, we thought of a table as a bunch of columns. So now our table looks like this. We still have the outline of a table, but instead of defining the row, we have this gray box. So each column has a header and then a list of repeated cells within that column. And so if we go through and look at some of the code here, a column looks like this. The header cell is the name, and then our data, which gets repeated, is the data name.
Cool. And then what do we need to do next is tell it what columns do you want to display. So then we have our header row and our row, and all we need to do is give it a reference to the columns that we've defined earlier in their containers.
So putting this all together here, we still have our large layout. So first you define the name column, then you define a movie column, and then you put it all together.
Yeah, we know the interface, it looks harder. It looks a little less intuitive. It's confusing. But the benefit is it gave us control, right? It gave us the ability to know all about the cells, the rows, the header row, and the columns, right? And that fit all of our requirements for a table that needed to be performant and fast and understand your intent of how you wanted to use the table.
So we're able to have those row-based features that weren't, or column-based features that weren't possible with the rows earlier. So we can reorder these just by changing the order in that array. Now, after talking about the layout and going with this column-based design, we're going to go into the second part of our talk, which is the data source. And so as we said, the data source is the brain.
It's the brains, right? So what you're going to do is, if you want to talk to the table and tell it what rows you want to render, you go through the data source. So think of your data source as the guy that's modular, where you're going to put all the logic about what rows do I want to display to the user, and then the benefit being that you can use that data source anywhere else, right? So say we have a couple names here, Aaron and Andrew. We give it to the data source, and it's going to say, all right, I'll tell the table, render out Aaron and Andrew. Great, simple. Now, if we added another guy here, Rob, all right, data source says I saw a change. I'm going to let the table know, hey, something has changed. Go ahead and render that out.
Admittedly, this is not the most interesting use of a data source. It just gets passed the data directly through the table to render. But let's say we have something else in here. Let's say we add sorting. So sorting gets passed into the data source along with our database or our information. The table then only is listening to this one stream. It's able to see the result in the rows that the data source decides, and it just renders it. So adding another one.
Another one, we got filtering, right? So now we've got, let's say the user types E in some filter box. So now the data source is going to say, I know my data, I know the sorting arrangement, and I know that I need a filter on E. So what am I going to do to process that to send it off to the table? I'm going to show Aaron and Andrew.
Yeah, and we can imagine this with any type of database. So we had just an array of data, but you can imagine some more of a real-time one, like a Firebase, for instance, here. And more information, so paging and more complex filtering or triggers. So anything that you want to add to the table goes into this data source, and then the CDK table just renders it. And with that, we're going to go into a demo. So I said I had a bakery. It's called Baked Cake. And this bakery, Andrew and I just got word from our manager, and she wants us to build an app so we can see all of our orders. So table seems good for that. Let's go and see what it looks like.
All right, so let's dive into the app. All right, so here's what we have so far. So what I've done is I've created a new app with the CLI. You guys all know the process. There's just a basic layout, some styles here. There's no logic. And let's see what the code looks like. So here's our app component. It's fairly simple. It has one thing, a data source. Okay, so we're going to start with one pre-built for us. And it does a very simple job, right? So we're injecting into our app component some database. And I don't know any information about the database except that it provides some stream of data, orders. Yeah. Okay, now when I create my data source, I pass the orders along to the data source.
And the data source itself is pretty simple. Can we look at it real fast, Andrew?
Right. So the implementation for data source.
So there's really only two parts of this. So first we have our connect method. And this is just that one stream of data we kept seeing being passed from the data source to our table. And the second part is this disconnect method. And so disconnect is just the type of cleanup you want. So cleaning up any observables, any unsubscribes, or anything you like in that regard.
All right, so back to our app component. So we want a table. Let's put a table in here, right? Let's go to our HTML and see what we got. So I got to figure out where the table goes, and I think it goes in the table.
Yeah, I think there's a spot right here. That's
okay.
Where we can put it. It seems good.
So we're going to start with a mat component, a mat table. Now, so we did mention the CDK table. The mat table is just a CDK table with some 16 lines of styles to it to make it look like the mat material style.
Yeah. So like you guys are able to build on top of it, we built on top of it for the material table, Angular material table. So we passed in our data source with the list of orders. And the first thing we want to do here is build a column.
We need a column, right? We need column definitions. And so let's start with a column definition, right? And let's look back at our data and see what kind of stuff we want to display. So look on the top here. So our bakery orders, they have a few different things in here. And I see one thing, order ID. So let's start with that. Yeah. So let's go under HTML. We'll make a column for order ID. Mm-hmm. Let's do this. All right, so what I've just created here was a container. The name is order ID. The header cell you see will just say order ID. And the cell for the data rows are just going to access the data property for order ID. Mm-hmm. Very simple, right?
Yeah.
Now we need one more thing. Let's put in our rows, because we need to tell the table what columns do you want to display in these rows. So you see here that there's an array, order ID. All right. I think that's it.
Now we have a table, right?
See if it works. There we are.
Oh, nice.
Hey,
awesome.
there it is. And it scrolls.
Yeah, there's a lot of items in there.
We've got all of our data. So not too impressive.
I don't think my manager's going to like this.
Let's put more.
She doesn't know about the cost or what we're ordering. Yeah, let's add some more information.
So I want to add more columns. I'm going to do a shortcut to add a bunch more columns, right? But they're all the same thing, basically. But it's just for the rest of the data, right? So I've added 6 more columns for the item, the flavor, customer cost, quantity. Great. And so if we see our table, still says order ID.
I don't see everything else in there.
No. So what are we missing?
Oh, we have to update the row.
That's right. All right. So let's tell it what columns and what order we want them to display in. So the best way probably to do that is start making a variable.
Yeah. And the power of creating this variable and not defining it all in your template is that we can then hide columns, reorder columns, and we really get that the benefit of defining these columns here. So if I wanted to remove one, I just delete it from my array and it goes away. So we can imagine more components interacting with this.
All right.
So finish writing this out.
Okay, save. No.
Yeah.
There we go. All
awesome.
right, now we got a bunch of data. We're showing a real table. Again, scroll, lots of data in here.
That is a lot of data.
It's kind of a lot of data, right? A little overwhelming. What can we do about that?
Well, I think we can add some kind of paging components.
Paging would be good. That'd be
if
good
I remember, the material table also has paging components and sorting components built in with it. So let's use the map paginator here instead.
Cool. So here we go. Map paginator comes with the library. Let me scroll this way a little bit. So all we're doing right now is telling it how long is our orders database orders length right now, right? So now this should show up in the app.
Yeah.
There we go. Now we got something that looks like a table, right? So we got a title on it. We've got the rows. We've got a paginator.
So does it work?
So we still got a lot of data in here, and So it doesn't look like it's working yet, right? What are we missing?
Oh, the streams. So we have
Right.
to add some kind of event in here in some way to tell the data source that this paginator is changing.
So the map paginator does emit an event page, and it tells us what page does the user want to see and how long is that page going to be. The best way to do that, right, is we've got a data source. It's the brains of our operations. So when this page event happens, let's tell our data source that something has happened. So we're going to go into our data source here, and we're going to add a subject, a stream, that the paginator can then talk to tell the data source something has changed. Now, in our connect function to the table, we need to tell there's more things than just orders.
Yeah, so here we're going to actually use a combine latest with the observable. So we want to take the latest from our database and the latest from this paginator information and actually combine them into what we're actually passing to the table.
So I'm going to take the result, and the result contains an array of two things, the orders and the page. And so let's just make some function, get page data, and I'll pass it those two things, right? All right, so now let's actually make that function, and I'll perform some magic here. And there we go. And we got to get page data. And all it does is it gets the orders, it does some math, it says what slice of the data should we show.
And one of the interesting things here is this orders.slice. And so what this is doing is this is creating a copy of our data and really helping maintain the immutability here. So we don't want to actually be changing our actual data, and the table gets that new information.
So last bit, we need to connect up the map paginator with the data source.
Mm-hmm.
Let's see what that looks like here. So in the page, let's tell the data source, go to the page changes, emit the next value, and send in the event from our paginator.
Awesome.
Hit save, and
So this should work now.
let's see.
That looks like less.
Does it refresh?
Oh.
Nope. All right, what are we missing here? Let's see. So we've got the page, we told the orders. Return that.
Sure, just hit next.
Yeah.
Let's try paging.
No. Try paging.
Yeah,
Oh, okay.
It was working the
My
whole time.
apologies. It was working. I should hit the next button. And this is 50 items. I'm
Now-
sorry.
there we go. Now there's
All right,
a lot
so
less
we're
items
good.
here.
We're good. Everything is set up.
Okay.
Cool. So you're looking at this now, right? This matches the material spec. It looks like a table, and this is something you'd want. But we said you can build upon it, right? And we kind of showed that process. And what I want to do is click this button up here, and it's going to highlight our components and show how did we build this thing out to the user. It looks like a single solid table, but for you guys, behind the scenes, you've customized this, right? So the top, it's just a div, it's a header. Below that, you've got the actual table, and then even further, you've got the map paginator.
And if we wanted to swap the paginator with our own custom paginator for our bakery, we can do that. So we can add the go-to page without actually making any changes to the table. So as we went through and did this, we touched the paginator and the data source, but we didn't touch anything about the way the table is displayed. So this is the separation of responsibilities between the data source and our template.
All right, so we do have a bake shop.
We do.
And we want to open the doors. So we want orders to come in and write any database that will be changing. And we kind of want to show these changes in the table. Right?
Yeah, I want to see them as they're coming in. I want to know what my next order is right away.
So let's think. So our database, it had a stream of orders. We sent that, let's look at the code here. We sent that to the data source, and it's listening to the orders and the page changes. It does some math, figures out what should happen.
But it's all streams here. So,
streams.
Our database is a stream of data, and our pages are a stream of data.
So I don't think we have to change anything if we wanted to turn on real time, right? So think of maybe a Firebase database. Let's turn on the real-time orders, and hey, things are changing, things are showing up. We've got a stream of stuff coming on in.
And we didn't have to change anything.
We didn't have to change anything at all. So that works. Yeah, it's good. It comes in, but users, they see this, they see jank, right? They don't know kind of what happened here.
We just
know
have
rows are
things
coming
jumping in. Maybe if we add some kind of animation in here.
Animations would be good. All right.
I've heard animations are really hard, though.
So Angular does come with a good animations framework, so let's try to leverage it. So what I want to do, here's my goal. when a new row comes in, and it's a new processing order from the baking shop, I want it to kind of transition in, right? I want to show the users, like, this thing is the brand new thing. So in our template, since we do have a handle on the mat row, which is the thing the table is stamping out in the view, I can add an animation trigger right on this guy. And if you see here the let order, that order I can access, and for every data row, we'll have the individual order for that data. Okay. So let's try setting up some state trigger. I'm going to call it state. And it's going to look at the order status. All right, so let's go back to our app component. And in the metadata, we can add in some animations. And I've got one here, and it's real simple. It says when something goes from void to processing, which is a new row that starts with processing, do some kind of height thing, right?
Okay.
So let's see what that looks like here. We'll turn on real-time orders.
Hey!
Looks a lot nicer. All right, so now users know kind of like things are coming in, things are streaming, and looks
we didn't
pretty
touch
good.
the data source for this one.
So we didn't touch the data source, and really, what was that? 5 lines of code, right? And you add a little bit of polish and a little bit nice kind of look and feel to your data table. I like it.
I like it. I think
works out
that's
pretty
going to
good.
make my manager very happy.
All right. I think we're set.
Yeah.
That's a good one. All right, so I think we got our app all set up. Let's look back at our slides here and kind of go over what we talked about here.
There we go. And so what we want to take away is that the Angular material data table exists. You can use this today in your applications, and it's out of beta.
It's out of beta. We're excited about that. Second thing, you can build anything with the CDK table, right? So you own the view, you own the data source, you own the logic about what shows up. We're going to focus on being as performant as possible, but we want you guys to build with us. And over time, we'll provide things. We'll add sugar to the interface. We'll make things a little bit easier if you want a simple table. We can even add in selection columns and such, and you guys can join us and build great things with this table.
Thank you.
Yeah, thanks for coming, guys. Pleasure.
Thank you.
Oh my goodness.
Because it was your work anniversary, and we tried really hard to find a candle.
Yes.
But well, we have some fire hazard stuff going on, so we were not really allowed. But this is for both of you.
Thank you very
and
much.
Happy anniversary
Thank
to
you.
you.
Appreciate it.
Yeah.
Thank you, guys. Thanks.
Thank you. Oh, there's candles.
my word.
Oh wait, we
And
managed.
another one.
Good as a bakery.
You guys are great. You guys are so
Oh,
nice.
wow. You guys are amazing. Thank you.
Appreciate it.
Yeah.
Cool. Thanks, guys.
Thank you.
Thanks for joining.
Gotta get rid of that. So we're gonna have a break now, and then after the break in the Jupyter room, we're gonna have Angular Firms with Kara. And then here we're gonna have Sunny with 4-way data binding with Angular and PouchDB. And then in the Venus room, we're gonna have a virtual reality workshop. And in Pluto, we're gonna have the migration panel. So choose your track, and I'll see you back later. Enjoy your break.
Hey, hey.
Welcome back. So just before Sunny, we have a quick talk from Infragistics. They're one of our sponsors.
Thank you.
Thank you for joining us.
Thank you for having us.
Yeah, and they're going to describe a little bit. You're going to talk a little bit about your company and
Yep.
also how you help developers with design and productivity tools.
You got it.
Did I make it?
You got it. That
Give
was
me a
awesome.
high five. Woo!
Thank you.
Thank you.
Thank you. Okay, so thanks everyone for coming here for this pre-session before the session. We have about 5 minutes. My name's Jason. This is Spaz. We're from Infragistics. We've been in business for about 30 years. We build reusable component libraries across the spectrum of developer platforms. Angular is our focus now. We have a booth outside, so please come by if you want to learn more about us later. What Spaz is going to talk about today is to continue on what the keynote covered, which is taking a Sketch UI kit or a design system and driving that into your Angular app to make beautiful experiences, because really the UX is what counts. We have grids, charts, calendars, everything you can imagine to build an Angular app. And he's going to demo a little bit of that today using Sketch and how a designer might approach this with a developer from a design developer workflow. So Spaz, take it away.
Thank you, Jason.
Thanks.
So I'm going to be trying to be really fast and not focus on little details. But so what we have here is a UI kit in Sketch with all the components that we have, all our Angular components that we have. And they're perfectly mapped, and most of them are even responsive within Sketch. So I can basically move around most of the components, and they're going to scale the way they would scale after being implemented. So let's say we have a quick task that we have to do with a developer friend of mine and colleague, and that's actually a real task that we did in one day. So what we had to do was make a grid, and the grid was, let's say, a Boston Marathon themed grid. So I'm looking at my UI kit, and I'm going to pick up some components from there. So I want to give the people an avatar and possibly a badge. I'm going to copy it in another document. I'm just going to align it here. Obviously, I want to go to the grids because it's going to be a grid, and pick up something for the name, something for the number. Let's say, so this is going to be the position. This is going to be the name. I'm going to have some stats, most probably. So I'm going to copy it a little bit here. I'm going to go all the way into this window. Let's bring my tool set. So good things that we did for our components is that we made them very optimizable and changeable. So you can change the icon with some pre-built preset icons here. So let's say we have a trophy because he's the first in line. I can also change the colors from a palette that you can define beforehand or change afterwards. So let's say I want to make the cup white. And little by little, playing little by little, I was able to quickly come up to this. So you saw the icon, the names and everything. I have a header section, and also the great thing is that this is responsive, so I can see it on all kinds of devices and all kinds of resolutions, how it would look. So what happened next? I gave it to the developer, and the developer was quickly able to put together a sample in Plunker. So let me show you. Oh dear. So it's loaded here. I'm not going to show you the full preview. So as you can see, we have everything that I put together. It's in here, and it's right out of the box. Quickly, he was able to do the design I did and make it in code, functional, and ready to use. You can check out the UI kit. It's on GitHub. It's free. You can download it, give it a spin, and also you can go on our repo for the JS Blocks product that you can download and fork or like and star and all that, and just give it a spin, give it a try. So if Jason wants to.
All right, thanks. So basically what happens, and we could only do like 5 minutes, is you always have a designer who's trying to do things, and a lot of times the developer's given a task, and what comes out of the other end isn't beautiful, isn't awesome, and it doesn't really match what the business needs. So that's where the visual design perspective comes in. So you can have a whole design team using things like our UI kits, like a design library, to create the entire application with a tool like Sketch, and then output that on a one-to-one basis because our UI toolkit maps to the Sketch widgets, and that's really where you get the benefit. We have other products as well, another product called Indigo Studio, which is a UX wireframing and prototyping tool. You can do a similar type design experience with that, and that'll actually generate code output for JavaScript. So if you have a designer, a UX designer, and a visual designer working together, you can take that, export that out, and you have a starting point for where you want to go next. What we're doing in terms of our roadmap is we're going to continue to build plugins for Sketch to help generate Angular code automatically. We are going to make it even easier for you to take something that a designer has, make it really beautiful, and output to something that your customers want. So our sweet spot in the market is not only design, but it has to do with high-powered, high-volume data grids and data charts. So that's our time is up now. Thank you for the 5 minutes. Please come see us at our booth on the other hallway over there. And thank you for your time, and thank you, Spaz.
Thank you.
Thank you.
Thank you.
Okay, so next up, you look confused. Do you need to set up? Yeah, go ahead. So next up we have Sunny, who's, well, he's a very special speaker. He's like this sunshine and ball of energy. It's like very hard to keep up with you. No, but honestly, he's a really, really nice guy and also very knowledgeable, and he's doing a lot in the Angular community. So thank you for that, Sunny.
Thank you very much, Cameron.
Yeah, well, take it away.
Okay.
Enjoy.
Thank you very much, Carmen, for that great intro. Hello, everybody. Hi. So today we're going to talk about four-way data binding with Angular, and I'll explain as I go on. Just before I begin, let's get the boring stuff out of the way. This is the part I tell you about myself, and so my name is Sani. I live here in London. I'm originally Nigerian. So I'm the founder of Hybrid, a small consultancy here based in London. I travel around the world to train people in Angular and a lot of Ionic stuff as well. And I'm a big fan of the Avatar franchise. Like, has anybody seen that movie? Has anybody not seen the movie? Okay. We know who we're going to kick out now. All right. You can find me online at Sani Yusuf, SANIYUSUF. Pretty much, if you find anyone using that username and they don't look like me, please let me know. Yeah, so I can be suing people. So my goal today is, first of all, to talk about offline. Because offline is something that, as app developers, we completely forget. And I guess we've gotten that type of sort of like behavior because we've always made web applications. We've always thought the internet is just going to be available. It's going to be fast. It's going to be available. But now the line between a web app, a website, and a mobile application is really becoming thinner and thinner. So I'm going to talk about a little about that. I'm going to show you what's available today. So it's sort of like the offline stuff that we have today, how it works. We're going to talk about then four-way data binding. I'll show you what exactly I mean by the term four-way data binding. And I can also talk about where we can actually improve as a community in terms of the things we're doing with our applications. So offline, this is a word you hear a lot. People talk about offline, but what really is offline? Like, what really constitutes an offline state, right? So I think the first one we know is when a user loses all connection to the internet, right? You're in a train somewhere, you don't have any service bars or stuff like that, or you go on airplane mode or something like that, right? You're on a flight somewhere, you have no access to the internet at all. So to talk about that a little bit, to give a bit of background, what I'm going to do is I'm going to take you on a journey. It's sort of like we're going to consider a particular scenario. So in 2017, we've sent people to the moon. There's a guy that wants you to travel around the world in an hour with a shuttle. Like, we've invented all these great things, right? But when you go offline on your browser, that's the best thing you can see. Like, that's the best offline experience. You can play a dinosaur game. Like, literally, this is the state of offline today. And how do users normally get here? When they completely lose connection once again, or they're on airplane mode. This is how you'd expect users to get to this type of state. So, in terms of in the app ecosystem, who is actually doing offline right? I'll be very honest with you, and trust me, this is not like a promotional thing, but Google tends to do offline pretty good. Things like Gmail, Android, Google Play Music, and WhatsApp as well. So they do offline really well. But why would I say that they do offline really well? Like, how did I get there? So what are the things that they actually do very, very well, right? So I spent some time, I use all of those applications. The first thing you notice is they only show you like the offline state at the point of transaction. When you're using Gmail, at no point would Gmail tell you you're offline until you actually need to send an email. And it will let you know, okay, I'll save this email, but when you come online, it will come. But right now, if you expect it to go ASAP, it's not going to happen because you do not have connection. And that's okay. But there are some applications that need to let you know that you're offline. Like if you're monitoring a Bitcoin pricing application or stock, you don't want to be seeing Bitcoin prices from like last year. You want to see what's happening now. So you'd want to be notified. So basically, you need to choose what is the point of transaction to actually show that. And Google Maps is another one. It needs to tell you that you're offline because if you're going to be searching things, it should be telling you this is coming, like this is either maybe cache data or not fresh data. And WhatsApp takes another route where WhatsApp lets you actually do the transaction, but then gives you a notification say, okay, 1 tick means it's actually gone to the server, 2 tick means the person it's been delivered and it's been read, or it's not gone, so it hasn't left your machine. So that's pretty good, but that's sort of letting the user know the state of their transaction. But there's also flaky connection, right? Because sometimes you have connection, but you can't actually use the internet. You can't actually connect to some sort of like data point. And this is, does anybody know what this is? This is what I call Li-Fi, like literally. No, it's not my term, but it's basically your phone, you see a couple of bars or like on your phone, you think you have connection, but actually your phone doesn't know what it's doing. There's no connection. It's just basically going around saying, oh, let me try to connect to something. And you as a user, you think that there's connection. And we've actually gone ahead to fix this lately. There's a lot of stuff in the community that's come out to fix this. The service worker has come through now, and Safari is finally implementing service worker. I never knew I'd be alive the day Apple would actually do the service worker. That's great. But yeah, so the service worker allows you to now manage a lot of like bad connection states. How does it do that? This is how the service worker works. So in case you're not familiar with what the service worker is, it's a new browser standard that sort of like sits as a proxy in between the server and your application. So when you send network requests, they go through the service worker first and then go to the network. And when they're coming back, they take the service worker first and then into your app. Now, why is that really cool? That means now you can actually work offline and you can cache a lot of data. And in case you're trying to get like a picture, but it's not really working out for you, you can sort of like get something from the cache. Makes your app experience way much faster and better. So we can say in today, 2017, the flaky connection is not really something we really think about. It's not really something we worry about as well as we normally used to. But what about what we're actually here to talk about, which is complete network loss? You're on a train somewhere or you're on a transatlantic flight, and imagine if you were on a transatlantic flight and you couldn't search through your old Gmail, emails. That would really suck. Or you would open Instagram and you couldn't really see anything. I wouldn't want that. Or think about an app like maybe Wunderlist or Evernote. I couldn't really create a note because I didn't have connection. In 2017, that's simply not acceptable. You want to be able to manage that. So let me tell you a bit about our own scenario with the contract I've been working on for the past year. Is we have these caseworkers that go and help a lot of patients, and they interview these patients on, in job centers and everything. These are people that have been out of work for a while, so they on the benefit system. So they interview them with long, questionnaires and everything like that, and then they go meet all these guys around town, and they have to go back to the office to type these things, So you've gotten the information, now you have to go home and actually spend another time, which you're not getting paid for, to actually type up the information you've gotten. So we saw that, we were like, this is simply not acceptable. Why do they do that? And they said the reason is because they can't take their machines. But even if they do take their machines, they need internet. And internet is not really, in a job center, you might not get the best network. So it doesn't really work for them. So we were like, it's crazy. In 2017, are you serious? So this is how it should be. They should be able to just meet these clients and just give them a tablet or computer, fill the information right there, and whether there's connection or not is not even a question. It should just go in, and then when they finally get to some connection, then the information will just sync up automatically. And if there's a problem with sync, maybe there's something didn't sync properly, you should be notified that this is the state of your transaction. So how did we solve that particular problem? So we used PouchDB. Now, what is PouchDB? So PouchDB is basically a front-end technology that sits on the client side. It's a browser-based storage system. It can harness, you can configure it to harness IndexedDB, WebSQL, local storage, and session storage, depending on your use case, or even in memory. So it's sort of like it sits on the client side, it creates a client-side database that you transact with it via like JSON, and you just work with that. It has a completely flat structure, so that you don't have things like maybe, arrays or like you can't do nested level stuff. It's very, very flat, but there's some, things that you can actually do to overcome that sort of like limitation. And it's for a reason, it's because we want to be very, very performant. And it has the greatest selling point of PouchDB is its sync capability and conflict resolution. So what if 3 people want to write to the same data at the same time? What happens if 3 people have gone offline? This is where it really shines, and I'll talk to you about that. So if you're working on a Cordova application, you can actually extend it with SQLite so that the PouchDB will work with your native Cordova side of things. It's also revision-based, so everything you post on PouchDB is like a revision. So every document, if I have like my user profile, for example, when I make a change to that user profile, the document is actually a new revision gets created. So you're always having access to the latest revision. So it's sort of like Git, but you can always also like go back down the tree to say, okay, what was this data like the very first day, or like the last time it was written in? So it's sort of like a Git a repository of each specific data has a revision-based system. So it looks like that you have like an ID and a revision ID that you can query specific revisions. Because if somebody is offline and another person has like a latest version of data, that person, both of them can still use the app even though they have different revisions, which makes it great to handle conflicts. It allows you to do a lot of CRUD operations. You can do a port operation, which allows you to send data with your own user-generated ID. And this is really good when you're like moving across, maybe you're migrating from one platform to another. And that's also how you update data with the put. And then you also have the post operation, which allows you to post data, but it automatically generates the ID for you, so you don't have to worry about that. Then you have a get operation, which basically just lets you retrieve data. And you can also retrieve a specific revision. If you don't want the latest, you want maybe a specific revision, you can pass that revision ID and get it. And you have, of course, remove, which allows you to just remove something out of the database. But yeah, like some of you are like, I've said the word 4-way data binding, like I haven't even talked about the bloody thing, right? So let's see what I mean by 4-way data binding. We love to stay in sync as developers. Data changes very easily. Think about Facebook. Like, you're on a thread or Twitter, people are liking and sharing, so much is changing. And if I'm on Instagram, I like to use Instagram a lot. If I like this very beautiful picture that I've seen on Instagram, I want that to sync when I do come back online. So we're very familiar with 2-way data binding, which is what Angular bought for us, which is basically gluing the view and the model together, making sure that once one changes, if you make a change from the view, the model will change. So if the data that holds, for example, on Facebook, the number of likes, if I change likes, I don't need to refresh. It just automatically changes that value. And then Firebase came and made the notion of 3-way data binding, basically taking that to the next level and making sure if you make a change from the server, you get it as a user, if you make a change on any of these levels. So for example, if this particular post I have has been liked 200 times, but I don't have connection, and somebody likes it elsewhere to 201, I should be able to get that because that's coming from the server. But then comes 4-way data binding. This is basically where we do all of that, but we also glue the local database, because what happens when the server is not reachable? Which point of data is the source of truth? This is where we all get confused. We're like, okay, which one do I believe now? But if you have a local database that's sort of like a reflection of the data the user needs, then that's your primary source of truth, and that reconciles with the server. So let's live replication and sync is something, but now I'm actually gonna go ahead and show you some stuff, a little demo I built. So I'm just gonna do this first. I'm going to show my screen bar. So I created this app called Chasu. So like I said, I'm Nigerian. Chasu is a word in the Hausa language, which I actually speak. It's a West African language, which basically means like, like a little bit of dancing and just going on, just like music. You can translate it in so many ways. Somebody's probably watching me saying, I don't know what I'm saying, but yeah. So basically this is, I like a lot of like Afrobeat type music. And this is like a sort of like a to-do app, but just allows you to sort of like list some of your very favorite songs. So basically what it does is you just come here, you add a song. So I can just say, I can add a song called Zona, and I'm using the same image over and over again, but this is actually going to the server and actually posting a local server that I built here. And this local server is running on CouchDB. So one thing with CouchDB is it syncs up with any CouchDB-based database. So if you're using Clouden, Cloudbase, anything that supports the CouchDB protocol, you're good to go. And if I actually refresh this particular page, you can actually see that particular record. And if I go ahead now from the server, so now I'm in the server level. If I go ahead, no, actually, I want to call this song, I don't know, Michael Jackson, for example, and I save that. If I go back, I can actually see that basically that three-way data binding has happened. That's the point. But what if I like go offline now, in terms of here, I go offline, and then I actually now change the record from the server? What happens then? You want like an immediate sort of like refresh of data. So I can go ahead now and actually change this back to Zona, which basically means sit down. And if I go back, this hasn't changed, of course, because I'm supposed to be offline. But if I then come back online, and we give like some time if the internet doesn't fail us, that reconciliation should be able to happen now. Yeah, so we've seen that. So that means now when I'm offline, if I just go into the train and something has happened, as soon as I get out, I don't really need to worry. I'm just going to get the latest. But what about the other way around? What about if I go offline and I make an edit to this particular data? So I'll just say, just type the same thing now and edit this particular data. So to the user using the app, they don't really care. They're still being able to transact with that database. They can still push, pull, create new records, and do everything and remove records. But what they want is, they don't want to have to be the ones to handle that. When the network comes back, the server and your device should just be able to reconcile and create that four-way glue. So now let's actually go back, let's go online and actually wait for the CouchDB to do its magic. And if we give it some time, and we go back to this particular page, we do the table. So we just refresh this here. We actually go back to the table. So let's give it a while. Okay, so my syncing doesn't seem to be working properly now. Say that again? Oh, so I think I got confused there. So it did work. Oh, apologies. I thought I actually deleted, so I added back. Sorry, yes. Of course. Thank you for that. So it now syncs up. But where this is really cool is, what if you have multiple devices? What if this guy's somewhere around the world and they update the same record? That's where PouchDB really shines. So I'm just going to go back to the slides here. And this is where PouchDB has the live replication. So that's what I just showed, being able to replicate from the server downwards live. And you can catch so many events, like when the document, a specific document has changed, when the live replication has been paused, active, denied, so many things that you can sort of like handle. And the reason why you have this is because you want to be able to handle conflicts. And because different types of conflicts can happen. If you write the same data and I write to the same data, and we both come back online, who's the truth? Who's the source of truth? Most databases today just get the guy that just wrote it the latest, like, just give it to me. But what if I made a change in this device, and that's what the change I want, but I made the change in the other device, but this doesn't come online first? What happens then? If I see something newer that I'm not expecting, I want to be able to do that. And that's where that revision system really comes powerful, because then you can manage conflicts. And PouchDB will tell you that this file is in conflict because 2 people have tried to write it. Now I'm going to deterministically write this one, but if you need to handle that differently, you can just go ahead and take this particular revision and roll back. And this is pretty good. This is sort of like what a lot of apps do, where they show you, oh, on your iPhone, you actually wrote this, or on your Mac, you actually wrote it. They tell you what device as well, and then you can actually merge that type of conflict. So how does PouchDB actually go about this? So I talked about how it syncs with any CouchDB-based solution. So if you're using any CouchDB-based backend, you just get that syncing free. But even if you're not, think about you're using something like maybe Azure or something like that maybe doesn't necessarily have a front-end side. You can still use CouchDB and just create your own mapping to how you want it to go up. So you can create like a reflection of whatever database you have. You might not get the syncing because it's not CouchDB based, but at least it's a start. Your users would have a local, very, very mature, persistent local database, if that makes sense. So we talked about how it supports live replication, change detection, and some other great features is like, now since CouchDB 2, we've gotten the advanced MongoDB style query. So you can actually go and query things like, do a lot of like complex MapReduce type of things. You can like say you want to get specific type of data, and you can do filtered replication. Instead of replicating the entire database, you can replicate only the part the user needs. So if you have a user that has like 5 GB of database, you don't want to replicate that on the front end. You just want to replicate maybe the things that you really, really need, and you can specify that with PouchDB. So I want to say a special thanks to, Kevin, who actually is a developer I've worked with, and Kevin is the guy that got me into PouchDB, and Nolan Lawson as well, who is the guy that made PouchDB, and Joshua Maroney. Well, just before I go, I think the best thing I can do here is actually to show a bit of the code that actually made that little demo that we saw work. So I'm going to go back now to the code. The first thing here, this is an Angular application, by the way, that is built with Ionic. So it's pretty much just a normal Angular sort of like provider here. So I'm just going to open this. I'm going to go to the pages. I'm going to go to the home page here. So I kind of put everything in the home page to make it very easy to read. All I've done here is I've required PouchDB, which I installed via the npm, and I've created a new local database here. This is what I'm doing here. But if I wanted to, I don't want a local database, for example. I want to connect straight to the server. I can put my REST API there and connect straight. Because some apps don't want to say, if you're creating a bank application, you don't want a lot of that data on the front end side, things like that. And I'm specifying some options that I want live replication, and if the connection fails, I want it to retry automatically. Then this is my local host database that I created, and I'm now syncing them. So I'm saying my local data and this particular database we can sync. So this is very powerful because you can create different local databases and sync to different remote databases at the same time. And then I just get the data. I save that in some, property on my class. And whenever I'm creating, I just call the create to do function, which is somewhere down here, which actually just does the post. And we have the update to do. And also I have this handle change function, which if we go back to, this large enough, by the way, guys? All good? Okay. If we go back to here, you can see where I actually use the handle change, and I'm saying that whenever a change occurs, just run this particular function. It's sort of like a callback. And inside the handle change, I detect if it's a delete operation, remove operation, write operation, and I handle that the way I want to. And in case there's a conflict as well. So that's kind of like, in a nutshell, what the bare bones that made that particular demo possible. That's a very simple demo. But think about everything. You don't have to think about like the same way like I created their demo. Think about different types of application. Think about like a virtual reality, sort of like design your home. Let's say I just got married and I moved into this new house and we're designing our house virtually. And I put the couch here and I go offline and my wife comes online. She doesn't like where I put the couch and she does that. That's something I want to make sure syncs properly before I go buy the couch. So stuff like that, it allows you to do think about ways you can really use offline to do so many types of like really, really cool applications. So again, I would say special thanks to these people. You can get started today on the PouchDB website. There's a lot of really good offline stuff. The PouchDB website itself actually works offline. So as soon as you go there, and they've even added service worker. And some of the other things that people are doing are trying to merge PouchDB with something like to run in a separate thread in the JavaScript browser, to run with the service worker as well. So there's some really good experiments going on. If you have any time, I'm actually trying to start the Angular 2 PouchDB, or before Igor catches me, the Angular Pouch, library that would take advantage of observables so that you can just use streams now and make that really, really cool. So if you're really interested, hit me up in, on Twitter. If you want to learn about this as well, I'm teaching this in this new school I made online, so ui.school, you can go ahead and Pouch. This type of stuff is one of the things we're going to be talking about. Like I said, offline is every developer's responsibility. Always think about conflicts. Don't think that conflicts wouldn't happen. They will happen. If you're trying to use a tool that's like a database, and if you search the documentation for conflict and you don't see it, don't use it because it's not offline first, if offline first is your case. Yeah, you can find me online at sannyyusuf.com, and I'll be having the panels and everything today, and I'll be around all the time. So if you have any questions, please feel free to come up to me. I don't bite, maybe just a little bit. But thank you very, very much for listening to my talk.
Thank you.
Thanks, Carmen.
So let's have a quick 2 minutes break so that the next speakers can be set up. Next is Bonnie and Simpleton. Hey, that's your name. So yeah, just like a very quick 2 minutes break.
that's click for their talk. Where's Hello, everybody. Hello. Sorry for those of you that were here for Bonnie and Lucas's talk. We had some technical issues there, and very sorry about that. And sorry, Lucas. Let's give Lucas and Bonnie a round of applause for coming up here. So hopefully we're going to have those sorted. So we're actually going to put that talk on at 1:30. So that's during the lunch break. That gives you half an hour to get out and grab some food and come back in here. And then Lucas and Bonnie are going to be rocking it here at 1:30. So this next talk, I'm actually really, really excited about this. We've got 3 for the price of 1 here. So we've got Mike, he's an instructor at Egghead.io. He's a Google developer expert. I've been working on Angular tooling from way before Angular CLI days. And Philippe, who's been working on tooling as well, part of the Google team, and Hans as well, part of the Google team. So really, really excited to have them here. So give them a big round of applause.
All right. Hi, everybody. So show of hand here. Just who's using the CLI? Who's not using the CLI? Who raised their hands twice? Okay, some people actually raised their hands twice. I have some questions for you guys. Hi, everybody. We're the Angular CLI and DevKit team. We already been presented, so we're just going to go ahead. And I want to talk to you. We were going to talk to you about a lot of things today, but first I would just like to say that we released CLI 1.5.0 in honor of Alan Turing. Oh, yeah. Last week, sorry, November 1st. And with it came a lot of new features and a lot of improvements and bug fixes. And I want to talk a little bit about the 2 previous releases for a second for discussing the new features. So with 1.3 and 1.4, we introduced the build optimizer, which Philippe is going to talk a lot about, and it's an incredible piece of technology that just makes your apps faster, smaller, better, stronger. And we also released support for building Angular Universal. If you were to the keynote this morning, Jason Jean did a lot of that work, almost entire work for supporting Universal build. It's incredible. It works. It's super great. If you guys want to do server-side rendering at some point, this is the way to go. We also introduced naming chunks, which makes debugging a little bit better. And we introduced a new feature, a new library, which is called schematics. And I'm going to talk, and I'm going to come back later and talk about schematics a little bit for you guys, which is a workflow tool for the modern web. And with 1.5, we added even more features, a lot more. We added support for Angular 5, which comes with a new compiler, which is faster and even more powerful. We added support for ES 2015. So if you were working with evergreen browsers, if all your users are using evergreen browsers, you can get size and performance improvements by using ES 2015 output directly. And we also added better type checking with TypeScript so that your applications actually can give you more errors and more typing errors versus Angular 4 and Angular CLI 1.4. And we added this help for schematics, for custom schematics. So if you are developing custom schematics yourself, you can actually give your users, when they use ng-help, you can show all your options and everything that they can use. And we added better tree shaking and faster compilation and faster AOT compilation mostly. Just to show you how fast we're talking about, so these are the numbers for AOT compilation and non-AOT compilation in Angular CLI 1.4 and in Angular CLI 1.5. So we we worked really hard in making AOT compilation be the default for your app. And if your app is small or medium-sized, we're talking maybe 100, 200 files, using AOT compilation by default when you ng-serve will actually give you rebuilds, really fast rebuilds. So on Angular IO website, we went down to 1.2, 1.5 seconds rebuild times with AOT, which is just a little bit shy of twice the time of JIT. So you can actually use AOT when you develop now, so you don't have to worry about like errors that just come out of nowhere when you start building for prod, which is really great. And we also improved on size using the build optimizer for Angular IO. So in 1.3, we did not even have in 1.2, we did not even have the build optimizer. We introduced it in 1.3, and the numbers in 1.4 were incredible already. So we reduced about 45% of your app. And then in 1.5, we even went further than that and removed even more code. And the total is about 60% of your app from ng build prod is removed. 60% of your code will be eliminated, the code that you don't use, but the tooling doesn't know that you don't use. So we have Philippe who's going to talk a lot about that in a second, in a moment. But already, like, we are on the way to make your apps as slim and efficient as possible. And with that, I'm going to leave the stage. I'm going to let Mike Brokey take over. And he's going to talk about the CLI himself and the dev kit. So, Mike, thank you.
No local storage today. My name is Mike Brockie. I've been working on the CLI for almost 2 years now, and I've been happy with what I've been doing. So today, yes, go figure, I'm here to talk to you about the CLI. But not just the CLI today, talking about you as well. Talking about what you've done with the CLI and the growth that you've done. About a year and a half ago, we released the final version. Actually, it's been less than a year. Never mind. Anyway, lots of growth. Lots of people using it. We saw the show of hands earlier, so thank you for using the CLI. The feedback you've given us has been tremendous, and that's actually US. So I apologize. We'll go British. We need to have the British office up here in order to here at AngularConnect. But yes, seriously, thank you for using the CLI. It's been tremendous. But we know that the CLI is great as it is, but we're here to talk a little bit about the dev kit, or at least I am. The idea of the CLI and the dev kit is a symbiotic relationship, and we want to talk about what or why we're moving the CLI to the dev kit, what it's going to provide, and also a little bit of a roadmap of the different things that are going to be coming in the future. But rest assured, the CLI isn't going anywhere. You'll still be able to run all the same commands. It's just some internal things that we're doing to provide additional functionality. I'll talk about that here in a sec. So why? Why are we moving logic from the CLI into something called the dev kit? Well, we wanted to have cleaner code. So we have some legacy pieces within the CLI based off of some early architectural decisions that we want to try and clean up and provide us a cleaner code base to be able to provide additional things. We want our workflow to be more testable. This way, we're providing more reliable code to you as users of the CLI through the dev kit. Flexibility. It'll allow us, with having a more sound foundation within the dev kit than what's currently in the CLI internals, to be able to provide more functionality and flexibility to provide not only us with the tooling that we need, but also other options for you to add on to the CLI as well. Also, performance. We want things to be able to run faster, and if we write more efficient code, it'll run faster. Go figure. And not just for what we're writing internally, but also things that you're running. So small things like generate, you'll see some gains with what we're able to strip out and refactor within there. And also, things like ng build are getting faster with work that Philippe's put on as well. So performance gains from what you run from the CLI, as well as the output there as well. and also unlocking other future possibilities. So what are we doing? A lot of refactoring. The way that I like to think about DevKit and the relationship with the CLI is like Angular development. You end up and you start writing your application, you write this component, and it's like, oh yeah, I want this little thing here and there, but it's got some logic, and I add more and more logic, and all of a sudden you've got a 200-line component file. So what do? You refactor it out into a service. Think of the DevKit as the service behind the CLI. So we're basically taking all that logic that's in the CLI and moving it into a library framework. This way it's not in the UI layer, which is the command line, it's moving it into a library. So doing the refactoring there. We've already moved things into DevKit, things that we've already done. Generating with schematics, starting with Angular CLI version 1.4. Schematics was being used to generate all of your new applications. All your components, services, pipes, anything else that you generated was already running through schematics and using DevKit as a version 1.4. Also, Build Optimizer is part of the DevKit. So all the pieces that Hans was talking about that Philippe will be up here in a second to talk to you about is all within the DevKit to provide that layer of flexibility and that extra layer for us for our architecture. And also Service Worker was introduced in version 1.6. So it's kind of, 1.6 is kind of in between the now and the future, but it's out in beta. It was talked a little bit during the keynote this morning and yesterday by Maxime in his PWA talk. So improved Service Worker with the Angular 5 improved Service Worker support is there. Also, I want to talk to you a little bit about the roadmap, but not quite yet. I'll come back later and finish that up. But we want to talk about what's there now. So I'm going to bring Philippe up to talk to you a little bit more about Build Optimizer.
Thanks. Hi. Okay, so I'm Philippe. I'm here to talk about Build Optimizer. So Build Optimizer is something that we introduced in 1.4. 1.5, if you've made a new project, you're probably using Build Optimizer right now whenever you do a prod build. And for projects in 1.4, you could opt into it via the -- Build Optimizer flag. So this is live right now, and we feel like it's quite mature and that we feel really good about it, so we turn it on by default. What is it, though? In the slide here, I say that it's a set of code transformations that make Angular app bundles smaller. By code transformations here, I mean that we move some code around, we add some comments, we remove tiny bits of code, but when we run that code that we generated via tooling, it gets much smaller than before. So we've gotten some numbers from Hans before. Let's see how small we're talking about here. Angular IO's app is our docs app, and we use it for benchmarks. Without Build Optimizer, it was nearly 1,200 Ks. With Build Optimizer, it's around 500. This is a big reduction. And essentially, the app lost nothing. This is just almost a refactoring of your generated code. But your mileage may really vary a bit. See, Build Optimizer works by removing unused library code. If your app uses most of the library code that it imports, there's just not a lot to lose there. But why do we need Build Optimizer? Shouldn't Uglify already take care of this? Well, the answer is that transpiled TypeScript code, sometimes it's hard for Uglify to actually drop statements out of. But we know more than Uglify in this case. We know that we're looking for transpiled Angular apps that were built using AOT. So we know what to look for here. We're looking for transpiled classes, we're looking for enums, we're looking for decorators, and we're looking for TypeScript helpers. But I should mention that TypeScript already does a lot of the transforms that we have here. Ideally, Build Optimizer wouldn't be needed. TypeScript right now does some of the transformations that we look for, but code in the wild itself, it doesn't have those transformations. So there's loads of code online right now that your apps use that still need Build Optimizer to shake out the bits that you don't actually use. The code that I'll show was transpiled using TypeScript 2.3.4. Let's see an example of what I'm talking about here. So I have some code. I hope that this is like everyone can read this. On the left, actually on the right, you can see the source TypeScript. And on the left, you see the transpiled JavaScript. See, so you have a couple of class declarations that get transformed into a couple of functions, and we're looking at a total of 5 declarations here. One for each class instantiation, and also one for a number. But only the class 1 is used here. And we're going to see what Uglify does to this code, and how many statements is Uglify actually able to drop. But I want to see if you can guess. Who here thinks that only one statement will be dropped? Put your hands up if you think, okay, out of this code, Uglify probably can only drop one. Okay. What if you think that it can drop two? Okay. Three? Do you think it can drop everything? Because, Uglify just realizes that our class is useless. Okay. The real answer is that it can drop two. The code there that you see in red is the code that's actually going to be dropped. And you might think this is weird because, you look at the code and this does nothing. Why couldn't it drop the class 2 instantiation? Well, because Uglify doesn't know what's actually happening there. By instantiating class 2, you might be doing a bunch of stuff. You might be calling APIs, you might be changing internal state, you might be just doing a bunch of console logs, and that's a side effect. So Uglify cannot drop it. But we know that this code does essentially nothing. So what we go and do here with Build Optimizer is that we add those little comments. You see those pure comments? Those comments mean this statement here has no side effects. So we added it to the class declarations, we added it to the class instantiations, and when we run this through Uglify, it's much, much smaller because the class instantiation for class 2 was dropped. And once that was dropped, the class declaration was dropped as well. So we're looking at toy code. This code does nothing. And just by adding a couple of comments, we've dropped roughly half of it. On real code, where real classes do stuff, once you drop a class, there's a lot less code there. But this effect also cascades. Once you drop a class or once you drop a declaration, there's more stuff that you can drop. And this is how, by keeping essentially the same app, on Angular I/O we got to half the size. This kind of relies on something that we know about Angular, though. Angular libraries are free from side effects. This isn't true of all libraries. So some of the more advanced transformations we can only really apply to Angular libraries, to the core ones, like Angular, Angular Core, Material, etc. Webpack 4 is actually working on supporting this concept of pure libraries so that library authors can mark on their package.json that this library doesn't have any side effects, and then Webpack will be able to drop a lot of this. Again, ideally, Build Optimizer wouldn't be needed, but tooling is getting there. Now we're going to look at the individual transformations that we apply. So because this is a pipeline, we apply a bunch of transformations, and in the end, we get the good results. This is the dangerous one, so to speak. This is called prefix functions. Here we call any function, we mark any function call as being free from side effects. And this is the one that we can really only apply to Angular libraries. My clicker is dead. No. Here we call this one prefix classes. It's kind of similar to the other one, but we look for TypeScript classes. We know that when they transpile, they look like this. And this is safe to apply anywhere. The class declaration in TypeScript is always free from side effects. This one is a little subtle. You see that there's a property downstairs, like outside of the declaration. That's in red. We're going to remove that, but we're going to put it inside of that IFI. This is very subtle, but when you look at this and when you think about what we were talking about before, about stuff not being used, just this little change made the class not actually be used anywhere but in its declaration. If that property was still outside, this class could never be dropped. So we call this one class fold. We have another one. This is called scrub file. This is the one that looks for Angular-specific things. We know that we're talking about code that has gone through AOT compilation. So we know that the Angular decorators that were only needed for AOT compilation, they can disappear. So here we look at an Angular decorator that's called injectable. We take it out, but we leave another decorator that's there. That didn't come from Angular, and we don't know if it's actually needed after AOT compilation. It probably is, because you added it. So we leave it. We only take the safe ones. And this can actually have a very dramatic effect when you use it on libraries, because it's a really good idea to inline your templates in libraries. But after we have the AOT factors, we don't need that anymore. So on libraries that have very big templates, running AOT compilation drops this big chunk of code. This is what a decorator with an inline template looks like in JavaScript. This is a bit more subtle. If you've seen bundled TypeScript code, you might have seen like these very common blocks of extends and something. This is actually generated by TypeScript. These are TypeScript helpers. As a TypeScript library author, you can actually say, I don't want to include these blocks, but instead I want to import them from tslib. But again, there's a lot of code in the wild that didn't do this. So we look for them specifically, and we replace them with imports. This might not seem very much to you, but these helpers would be in every transpiled TypeScript file. I think at some point, the RxJS published code had around, I don't know, some 200 of these. That kind of adds up. So replacing them with imports makes it a lot smaller. This is the last one, and this is a simple one as well. It's kind of the same principle as when we put that property in. We kind of don't want to have this and this is an enum being used anywhere but in its declaration, so we can drop it. So before we had a variable declaration, and then we had a function that actually used that variable declaration and added the enum bits. In this case, we're saying, well, enums, we know that enums are side effect free, and we're making it all in the single declaration. So if the enum isn't used, nothing else uses it, we can drop it. The last thing isn't a transformation, but it's actually something specific of Webpack code. Once you bundle Webpack code, you get it in its own bundle format. If you look at your Angular CLI bundles, you'll probably see a bunch of these Webpack requires. That's just the Webpack version of the node require. For libraries that are side effect free, we mark these as being also side effect free function calls, so that if you're not using some part of Angular, that whole file can be dropped and not imported at all. So how can you use this? Nowadays, if you make a project that uses Angular CLI 1.5 and Angular 5, you do nbg build -- prod, and you're already using Build Optimizer. So that's the most straightforward way. If you have an Angular 4 project, even if it's with Angular CLI 1.5, you still have to use the -- Build Optimizer flag. But you can also use Build Optimizer as a standalone library. You can use it, for instance, if you're trying to make your library smaller in some cases, or your app that doesn't use the Angular CLI smaller. You can just use it as a CLI tool. You install the package, and you just run Build Optimizer and then the input JavaScript. You can use it as a Webpack loader plus a plugin. And you can also import it as part of your build chain. And if you want, you can also import individual transformations, because Build Optimizer works as a TypeScript transformation, as actually several TypeScript transformations. And if you have a TypeScript pipeline that has your own transformations, you can just put these in there. That's going to work. But we have our full documentation and more examples and unit tests where you can actually check that these things work as we advertise in the DevKit repo. So I encourage you to go check there. And now I'm going to pass the clicker back to Hans. He's going to talk about schematics, which is really great. Thanks.
Thank you, Philippe. Thank you, that was great. And if you guys are not using the CLI, we still love you. You can use Build Optimizer too. So like a lot of our toolings, actually like the Webpack plugin and the Build Optimizer, you can use separately from the CLI, which is really great. I'm here today to talk mostly about schematics. And schematics is part of the Angular Labs experimental features. It's not yet ready to be, officially its own. It's part of a little bit of a nest, basically, that we call Angular Labs. And what is schematics? Schematics is a workflow tool for the modern web. And so workflows are basically when you pass from one project state to another project state. For example, you want to create a new component. That would be like a workflow. You add a component to your project. And workflows used to be a little bit like this. Basically, it's like somebody uses a file editor or a magnetized needle in a steady hand, and then just basically start creating new files, updating the files, and these are repeated often and often and often and every day multiple times. And you guys, like if I was asking you how many people in AngularJS were like creating new components every day from scratch, basically like creating a new file and calling like angular.module and everything. And so what you really need is building a script, a kind of workflow that goes from one state to another that creates. And so schematics create files. They also can rename and delete files, and they can transform and refactor files and logic. For an example of refactoring that we do, which is simple right now, but is that we add your component. When you create a new component, we add the component we import it automatically into the closest ng module. And schematics, we built schematics because what we were using before are basically just a bunch of, write file to the disk and all that. And we kind of noticed that, well, there are problems with these kind of workflows, which are like what Blueprints and Yeoman kind of use, which are when you write a file, you start the workflow, you write a bunch of files, and then like there is an error in the middle. Like you didn't npm install something that's required, or you didn't use the right file name, and suddenly there's a file that already exists. What happens? Well, the whole system breaks down. You're in this state, invalid state, where you have like half the process done and half the process not done. And so we created schematics to make sure that all the schematics are extensible, composable, and reusable. They're basically little sandbox where you get a state of the project, and then you build that state, and you pass that along. And you don't know what happens before, and you don't know what happened after. So you can actually put multiple schematics together, and all of them will work because they just work in the little sandbox, but they pipe those sandbox together. For example, our Angular application, we just put the files for creating the build, the configuration, the package JSON, the Angular CLI JSON. And after that, we call the same schematic that we use when you ng generate module. So literally, we're just reusing the same schematics that you guys that generate would be using for creating the base component and the base module and the tests and all that. And they're also atomic. So one of the great things is if something happens in your sandbox fails, but it does not necessarily, it didn't have any side effects. So it didn't create problems on the file system. And if you were part of a pipeline, people can actually just ignore the failure and say like, well, if this fails, I'm okay with that. Just continue on to the next one. And so schematics are just basically a rule, and we'll see what a rule is a little bit later, that takes an input tree and an output tree. And a tree is basically just a map of directories and files to their content. So a little bit of code. I want to show you guys a little bit how to create a schematic. So the way you create a schematic is you define a rule factory, and don't freak out about the word factory. It's basically just a function that takes an options. The options are basically provided for you externally, and it returns a rule. So for example, for an example of options, if you run ngGenerate --x equal y, options.x will be the string y. So it can come from the command line, or it can come from another schematics, and we'll see a little bit how to compose schematics in a bit. And so a rule takes a tree, applies something to it, and return another tree. And in this case, a rule is basically just a function that takes a tree, return a tree. And in this case, we're just going to create options.path. So we create a file at the path that you pass on the command line with the content hello world. And because schematics are already rules and factories are rule factories, you can actually call a rule factory with an object and with a list of options and get a rule. So you could technically just return another schematics like that. But how do you extend it? Well, we provide a lot of basic rules for you that makes composition and reusing really easy. For example, we provide chain, which chain basically chains multiple rules. And because the output of a rule is conveniently the input of another rule, we can just pipe them together, so chaining them together. And we're going to chain the other schematics with our tree.create that adds to the other schematic hello world, a file containing hello world. So if the paths already exist, or if the paths was created by another schematic, then this is going to do an error. In a system like Yeoman, for example, you might end up with another schematics being run, the file is being committed onto disk, and then you try to create a new file at options.path, that file exists, it breaks, but the other one just ran, so your file system actually is in an inconsistent state, and you have to git revert or maybe try to find out what happened. But in this case, if options.path already exists, it's going to discover that when you try to create, it will lead to an error down the line, and it will just prevent the whole system from being run. So this whole schematic will fail. But calling another schematics rule factory, so there is a little bit of helpers that we provide to create the options object. It's not just an options object. There is a schema. You can make a schema associated with it, and you can put like default values for some of its values, or you can compute some values with other values. And that logic is kind of lost if you call it directly as a function. So what we provide is the schematic rule, which calls another schematic by name with a set of options, and these options are going to be validated and then run against the schematic before running the other function. How do you get started with schematics? It's simple. So we provided, you have to install globally the schematics, the angular-devkit/schematics npm package. And you have to use, it depends on the core, the devkit core, and it depends on RxJS. And then we provide to you a schematics that helps you create schematic automatically. That's called @schematics/schematics. And so the schematics library provides you with a command line tool that's also called schematics. And that command line tool, and there is a schematics inside the schematics library that creates schematics, and so this is also called schematics. And so, I'm so sorry for the transcript, but to create a new schematics, you call schematics @schematics/schematics :schematic -- name equal Angular, the name that you want to give to that schematics. Yes, and so, or you can use the CLI. You can pass a collection to, and we'll talk about collection in a bit. You can use a CLI to actually remove one schematic from that command line if you don't like it. The difference, I just want to point out that the difference between schematics and CLI, the schematics command line tool, is that we only suggest the schematics for debugging. There is a lot less configuration that happens and validation that happens before schematics. So if you guys are targeting Angular CLI, then you should use the CLI at some point in your workflow to debug using the CLI. And then you can CD into AngularConnect. For our example, we're going to go into the new schematics that we created, and we're going to extend Angular, the schematics for Angular that we provide by default. So we released all our CLI templates basically as schematics as part of @schematics/Angular. Sorry. And creating the schematics will create a bunch of files. We'll go through all of these files. There is a lot of documentation in there that we're just going to skip. I suggest you guys, if you want to try it, you just try the command line previously, and then you just read through the documentation. This is really close to all the documentation that we can provide for now. Inside the package JSON, you'll notice that we added a new key that's schematics that point to a collection. A collection is basically a package of multiple schematics that contain a name and then a bunch of options. Like, for example, for this example, what we're going to use for the collection is we're going to create a new schematic that's called my schematic. There is a description, so if you do ng help, you're going to get the description. There is a factory, and optionally, the factory points to the rule factory, and optionally, there could be a schema in here. If you want an example of schema, there is a schematic that that contains a schema and all the validation that we support. And the factory itself points to the rule factory, which is in index.ts inside the my schematic folder. And so that function looks like this. So my schematics takes a list of options and return a rule. And then we call chain as we did before. But instead of calling schematic, we call external schematic, which takes two strings and an options object. The two strings are pointing to the collection and the schematic inside that collection. And then we just override, we just write over the component.css to pass in the selector and say that the color is red. So this is just a simple example of how you can extend an already existing schematic inside the Angular and add your own customizations to it. So what comes next? What is the roadmap? So right now, schematics has just been released as part of 1.4. We are working on a lot of the documentation, but also a lot of features that you guys are going to enjoy a lot. For example, we are working really hard at allowing you to extend collections. And what I mean by that is one part of reusability is that you want to basically just change one part of a collection that already exists. Like you want to change our components, but you still want to keep the others, like the generate module, generate spec, generate interface. You want to keep all of those. You can merge multiple collections, so we're going to allow you to merge multiple collections with different override options if you want to override some schematics from a different collection with other schematics from another collection. So if you have a company that has like multiple collections, and for a project you need multiple of them, then you can just merge them together and export them so that people can use them in ngGenerate. And another thing is maybe you want to reuse the same collection, reuse the same schematic that already exists in another collection, but you want to just change one part of it. So one thing that we're going to provide is the ability to add rules that will be applied at the end of other schematics. So for example, if you want to add the copyright notice at the top of every source files, you could have an add copyright rule that is added to all the schematics that already exist in another collection, like the Angular collection. And of course, you can mix and match merging and extending to really go further and apply rules to some part of a schematic or some other. Also, we want to add tasks. So one of the big problems currently is that because schematics have no side effects, well, this is a huge pro, but also schematics have no side effects, which is a huge con. And what we want is allow you to basically be able to use NPM or package manager, so that if the user, you just say, I want to run the install command on my package manager because I changed package.json. And we can already know if the user uses yarn or NPM or the Chinese NPM because they use a different one in China, for example. So you can just say, I want to install packages at the end because I changed package.json. And if multiple schematics ask for that command, we can just execute that command once because we know what it is. And we don't need to use npm install. We'll use the one that the user actually uses. Or you want to call git commit at the end to put a little pretty message or something. Or you want to use a database connection to update the database, your Firebase, only when the schematics have been successful. So if there's a problem generating schematics, you don't actually run the database update. And all of these are coming really, really soon. This is one of the next things that we're going to work. And finally, we want to have another command in the CLI that will be, we call it add, but name pending for now, that adds support for a library. So you have a project that already exists. You don't necessarily know, and you don't necessarily want to read like millions of tutorials on how to configure Firebase or install native scripts on your app and create like a bunch of files and all the dependencies and the imports and your ng modules. And so you could use ng add native script for that particular workflow. And we will work with these third parties to make sure that these are compatible with the CLI applications as they are today. And finally, we kind of used our own add schematic scope on NPM for our own stuff so far. We have 2 schematics, but we're going to add a few more in a bit. We want to open up that to basically everything that's endorsed by the main team are going to be part of the add schematic, so that you don't end up with random packages on NPM that you don't know if it's endorsed or not. Nobody knows if like @Paul/native script will be the official native script NPM package. Then we would like to be part of the add schematic so that you guys know that this is officially supported and endorsed by the Angular team. And so that is basically everything that's on the roadmap for schematics. And with that, I'm going to let Mike come back on stage to pop a little bit back the stack and go back to the CLI.
Thank you. I'm Mike again. So I promised you that we would talk a little bit about the roadmap of what's coming in the CLI and the dev kit in 2018 and beyond. So no promises on time frame, except today plus N is the way I like to refer to it, that sometime in the future, eventually, that these are some of the things that we'd like to be able to accomplish with the flexibility that we're providing within dev kit beyond schematics and build optimizer, which are wonderful additions to the CLI and dev kit. So without that, or more schematics is something we want to add an additional functionality within there. You saw some of the power that's really just like surface level of things that you can do. There's going to be a lot more that we can do with schematics and a lot more customizations that we can add, as well as things, if we're adding those things, then those are things that you can extend with your own schematics as well. So adding on to what we already have there. PWA support. Mentioned earlier, the 1.6 is supported in Service Worker 5. So that's currently in beta, and we're going to work to refine that to support PWAs through Service Worker at Manifest and the other pieces of PWAs so that you can get all the tooling for PWAs right out of the box with the CLI. Library support. A few of you, maybe like a handful over the entire Angular community, have asked for libraries. That's something that we're definitely working towards. We know that you want to be able to build libraries separately, not just applications, and it's something that we definitely want to support. We hear you, we want to work on it, but again, we're doing some internal cleanup, moving the dev kit that's going to unlock possibilities, like doing things like library support to be able to build libraries with the Angular CLI and the dev kit. Build hooks. As of right now, you have 2 options. You run your build through the CLI, or you eject and you run your own. And those are the 2 options that are there. So we want to be able to provide a little bit more granularity, whether or not it's just pre and post hooks or additional granularity to tap into the existing build system. Excuse me. So that will allow you to tap into the build system, whatever that ends up being, whether or not you're tapping into Webpack. There were also some talks here about ABC. Actually, I think Rado's talking about that later on today, about Angular basal enclosure. So whether or not that's the build system, to be able to tap into that to enhance your build process for your applications. Also, by moving things from a interface, a user interface, being the command line, into a library, the possibility of being able to tap into generations isn't just a command line thing. It could be a library that's consumed by an IDE. So imagine the possibility of, from Visual Studio, to be able to say, file, new, get a list of the schematics that are there from that IDE or any other IDE, to get that list, get that help to be able to have a user interface, to be able to find that if you're not so fond of the CLI or any other command line interface. So that's a possibility, or even a completely separate GUI. I know that there's some initiatives to be able to do a UI on top of the CLI right now, but it's a little difficult because you're taking an interface, a user interface, tapping into another user interface. So it'll clean it up by being more of a library in the dev kit. Also, add automatic updates. So talk about the ideas of what Hans had started on, is that you have a tree, and then you add some rules on top of that, and you get out another tree. Well, that doesn't necessarily need to be just generating an existing file. But maybe, so the example I like to use for this is with Angular 2 to Angular 4, the breaking change was to go the tags with a tag of template to ng template. Well, there's really nothing stopping you to write a schematic to say, hey, I'm going to look through your code, and I'm going to find anything that starts with a template, and I'm going to replace that with ng template. We've just upgraded an application from Angular 2 to Angular 4 by applying one rule. So any other rules we could also discern for any other future breaking changes to be able to apply rules to your system, look at your application, make those changes automatically for you, and spit out updated code for you. And that's just not limited to Angular. If you are updating another library that they decide to provide some sort of schematic scripts to be able to update your application for their libraries as well, if you're using any other third-party libraries. That functionality is all open to be able to tap into that. And as Hans mentioned, ng add. So scaling up a new piece. So the example I like for ng add is Firebase. You have to add your Firebase configuration somewhere. You have to add your npm installs to package.json and a few other things. But to be able to do all of that in a consistent way for you is very straightforward and something that's easily tapped into via schematics. So there's some of the things that we're looking forward to being able to expose and tap into the power that we're going to get out of the dev kit. So thank you for your time. Thank you again with Hans and Philippe for the work that they've done within the CLI, and thank you for coming out.
Thank you, guys. That was awesome. So a reminder again, 1:30 back here for Lucas's and Bonnie's talk on components of the new thin clients.